So in the previous lecture, we have seen the problems on strain displacement relation. Let us look into the problems of plane stress and plane strain today. Okay, let us look into this particular problem. In a plane strain problem, we have sigma x is equal to 20,000 psi, sigma y is equal to minus 10,000 psi, Young's modulus capital E is equal to 30 into 10 to the power of 6 psi, Poisson's ratio nu is equal to 0.3, and we are asked to find the stress sigma z. Okay, fine. We know what is psi. PSI is pound per square inch. Pound per square inch. PSI. Right? We can write it as LB, symbol as LB per inch square. Pound per square inch. Okay? This is normally, force per, the stress or pressure. So this is the FPS unit actually. This is not the SI unit. But for some, in some engineering applications, we represent the pressures or stresses in this particular notation, PSI, right? Say for example, if you go to any, if you want to fill up your air in the tire, then probably you would have seen that that particular the machine which gives you the pressure that will be rated as PSI, pound per square inch, right? So there are some applications still people use for pressure and all that, people use PSI, right? So if you have a in your refrigerator or in your air conditioning compressor, if you want to know the pressure inside that, people use that particular measuring thing. Yes, it will be there in both MKS as well as in FPS, pound per square inch. So it is also still in predominantly used, but mostly, even though FPS is used in US, in some applications we also use that. Okay, one second. Okay, fine. So let us quickly go into this. So what is the problem? In the problem, what is given? It is clearly mentioned that it is plane strain problem, right? Plane stress or plane strain. We know plane stress or plane strain. Both are for two dimension. Okay. Why do we consider plane stress or plane strain? Because we want to convert that 3 dimension to 2 dimension, right? Now it is clearly mentioned that this particular problem is plane strain. So we can understand that one dimension is very large. One dimension is very large when compared to the other two directions, right? Okay. So we are asked to find sigma z. There are two ways to do that. I'll tell you. For one way is, let us go with our stress strain relations. Let us go with our stress strain relations, right? By the way, what is the data given? Sigma x is 20,000 psi. Sigma y is minus 10,000 psi. Young's modulus capital E is 30 into 10 to the power of 6 psi. Poisson's ratio nu is 0.3 psi. Sorry, 0.3, not psi. It's Poisson's ratio, right? It's ratio. So no units. Fine. Now we are asked to find sigma z. Okay, so let us go to the stress strain relations. What are the stress strain relations? What are the stress strain relations? Epsilon x is equal to sigma x by E minus nu sigma y by E minus nu sigma z by E. I'm just writing it for the entire 3 dimension. Okay, and later on we can convert it. So epsilon y is sigma y by E minus nu sigma x by E minus nu sigma z by E. Similarly, epsilon z is equal to sigma z by E minus nu sigma x by E minus nu sigma y by E. What is gamma xy? Gamma xy is tau xy by g, but we know g is equal to E by 2 into 1 plus nu. So 1 by g becomes the reciprocal. So 1 by g is 2 into 1 plus nu by E into tau xy, right? Similarly, gamma yz is tau yz by g, 2 into 1 plus nu by E into tau yz. Similarly, gamma xz is equal to tau xz by g. So 1 by g is 2 into 1 plus nu by E into tau xz. So these are the three-dimensional stress strain relations. But now in the problem it is clearly mentioned that the problem is plane strain. Plane strain. So according to that, we know very well that in plane strain, if one dimension is very, very large in the z direction, if you consider a small portion, and in that that strain is considered to be zero. If normal strain is zero, if epsilon z is zero, then similarly gamma xz and gamma yz will also be zeros. Gamma xz will be zero and gamma yz will also be zeros, right? Because the normal strain is zero, so gamma xz and gamma yz, the shear strains in z direction, will also be zeros. Now, can anybody please respond to me? Is that clear to you?
Yes, sir. Absolutely.
Is that, is that clear to you? Now, yes. Today, I mean, because I have to look into the question kuda meeku chupistunnanu kabatti maybe you might have missed the bottom one, but I'll make sure that I can cover up the entire sheet. Okay? Here,
Sir,
yes. Can you able to look into the screen now?
sir, చెప్పండి.
Can you able to look into the video now?
Yes, sir. I'm able to look into the screen. Yes, sir.
Problem వచ్చిందా? Because someone has message like sir.
Yes, sir.
ఏంటమ్మా? Did you
Whiles and continues.
okay. Now you can put all your microphones off. Right? In plane strain is off. In epsilon z is 0. So correspondingly, in the shear strains correspond in that in z direction will also. So gamma xz and gamma y will be okay. See here, see gamma x for two dimension for plane stress or plane strain. For plane stress or plane strain, we only will have if this epsilon becomes epsilon x, epsilon y, gamma xy, and your stress becomes sigma x, tau xy, right? So here what we are asked to find? We are asked to find sigma z. Particular equation. I do not know epsilon x. I do not know epsilon x. I know sigma x, sigma y, nu, and e. In order to find this sigma z, I do not know epsilon x. There will be two unknowns then. Similarly, if I take this particular equation, epsilon y equation, then I do not know. If I want to find sigma z, then I do not know epsilon y. I know sigma x, sigma y, nu, and e. But again, I do not know epsilon y. If I take this particular equation, then in order to find sigma z, I know epsilon x, epsilon y, capital E, and I also know epsilon z. Why? Because for plane strain, it is clearly mentioned that the problem is, plane strain problem. Plane strain problem. So epsilon z will be 0. So I can directly substitute this 0, and so from here only one unknown, that is sigma z, and I can directly find sigma z. So I just want to take this particular equation, right? So what is sigma z? What is sigma z? Sigma z is equal to, oh sorry, epsilon z is equal to sigma z by e minus nu sigma x by e minus nu sigma y by e. What is epsilon? I should take it as 0, since strain equal to 0, and similarly we do not need it now, but xz as well as gamma yz will also be 0. If you have any doubt, you can go back to the previous. Okay, fine. So sigma z, do not know sigma z by e. I can take mu common. If I take mu common, then minus nu into sigma x plus sigma y by e. So if I sigma the other side, sigma z by e is equal to x sigma y e. I can cancel these keys. So sigma z is equal to 2 sigma x y. So what is sigma z now? What is nu? Poisson's ratio. What is Poisson's ratio? Poisson's ratio is 0. Poisson's ratio is 0.3. So sigma z is equal to 0.3 into what is sigma x? 20,000. What is sigma y? Minus 10,000. Right? So sigma z is equal to 0.3 into 20,000 minus 10,000. How much is that? 10,000. 10,000. 10,000 into 0.3. That is 3,000. PSI. Because already the stresses are given in PSI and we substituted them. So the units would be in PSI. Sigma z is equal to 3,000 PSI. So that is what we are asked to find. We are asked to find sigma z, and we got sigma z. See, whenever you get this plane stress or plane strain problems, just go back to those three-dimensional stress strain relations. Just go back to this three-dimensional stress strain relations. That's it. Whether it is plane stress or plane strain, you just go back to these equations, and these are you already know from your strength of materials, these equations, right? You can just go back to these equations and you can substitute. See, I can of course take this equation. I want to know sigma z, and I know if sigma x and sigma y, but I do not know epsilon x. But here, because it is plane strain, I can substitute sigma z as 0. So there will be only one unknown, that is sigma z. So I can get it. And that is the reason I haven't took any other equation. Okay. Fine. So what is the next problem? So I want you to look into this particular problem. Just go through this particular problem. The following stresses are developed in a plate. The following stresses are developed in a plate under plane stress. Just like in the previous problem, it is mentioned plane strain. Now in this problem, it is mentioned plane stress. Under plane stress, sigma xx is equal to 120 megapascal, sigma yy is equal to 14 megapascal, and sigma xy is equal to 5 megapascal. Determine the strain induced in the plate, assuming that capital G is equal to 209 gigapascal and Poisson's ratio is nu is equal to 0.3. I repeat it for you. The following stresses are developed in a plate under plane stress. Sigma xx is equal to 120 megapascal, sigma yy is equal to 14 megapascal, and sigma xy is equal to 5 megapascal. Determine the strain induced in the plate, assuming that Young's modulus capital E is equal to 209 gigapascal and Poisson's ratio is 0.3. Okay. First off, sigma xx is nothing but, actually we are supposed to write sigma xx. It's not sigma x, but we generally write sigma x. But what you mean by sigma x is normal stress in x direction. That is, it is acting on y plane in x direction. We are supposed to write sigma xx. Similarly, sigma yy. We are supposed to write sigma yy, but we simply write it as sigma y. Similarly, sigma xy is nothing but we represent it by tau xy so that we can differentiate normal and shear stresses. But actually, it should be written, I mean, people already also write in this way, sigma xy. So whenever we see xy, it is a plane. So it is not a normal stress, but it is shear stress. Or also you can have sigma yz, sigma xz. So then you can understand, okay, it is not normal stress, but it is shear stress. Just like you have tau xy. So I can also write this as tau yz. I can also write this as tau xz. Right? So we are given sigma x or sigma xx, sigma y in this notation. Sigma xx, sigma yy, and sigma xy. We are asked to find epsilon x. What we are asked to find? Determine the strain induced in the plate. What is strain for 2 dimension? How do I know that it is 2 dimension? Because it is clearly said the plate is under plane stress. Any object will be considered as 3 dimension, but according to the loading, according to the loading, we will consider it as either 2 dimension. I mean, we can convert that to 2 dimension, and in 2 dimension we have 2 cases. One is plane stress and the other one is plane strain. But this problem, it is clearly mentioned it is under plane stress. So we are asked to find the strain epsilon x, epsilon y, gamma xy. So for 2D, the strain is epsilon x, epsilon y, gamma xy. Obviously, you know stress is sigma x or sigma xx, sigma y or sigma yy, sigma xy, or we can also write it as tau xy. So this is stress and this is strain. One second. Okay. Okay. So for 2D, we know strain is epsilon x, epsilon y, gamma xy, and stress is sigma x, sigma y, and tau xy. Fine. Now again, as I told you, again we'll go back to we can do this problem in 2 ways. One is, because it is clearly mentioned it is plane stress, we can go back to that plane stress, Hooke's law, sigma is equal to d into epsilon. What is d matrix for plane stress? For plane stress. What is sigma, by the way? Plane stress or plane strain? It is 2D. So sigma x or sigma xx, sigma y or sigma yy, or sigma xy or tau xy is equal to, what is d matrix for plane stress? What is d matrix for plane stress? E by 1 minus nu square into 1 nu 0 nu 1 0 0 0 1 minus nu by 2 into what is epsilon? Epsilon strain matrix. Epsilon x, epsilon y, gamma xy. right? So in that, if I substitute all the values, then I know if sigma x, I know sigma y, I know tau xy, which is already given in the problem, which is already given, right? So what you need to find? So what you need to find? You need to find epsilon x. We are asked to find this matrix: epsilon x, epsilon y, gamma xy. You know E value is given, X modulus is given, Poisson's ratio is also given, mu is also given. So you know everything. So how to find out? Sigma x is equal to E by 1 minus mu square into 1 into epsilon x. I can write this as three equations. 1 into epsilon x plus mu into epsilon y. Mu into epsilon y plus 0 into something is 0. Sigma y is equal to E by 1 minus mu square into mu into epsilon x. Mu epsilon x plus 1 into epsilon y plus 0 into something 0. Similarly, tau xy is equal to E by 1 minus mu square into 0 into something 0 plus 0 into something 0 plus 1 minus mu by 2 into gamma xy. 1 minus mu by 2 into gamma xy. You can directly get gamma xy from here. If you take these two terms, you know E, you know epsilon, you know E, you know Poisson's ratio nu. If you take, you know tau xy, which is already given. So if you take this to the denominator, then you get gamma xy, right? You will get gamma xy. Similarly, from this is actually a value, E by 1 minus mu square. You know E and you know nu and you know sigma x is all x also. So you can have epsilon x plus, I'm just writing, you know nu 0.3 into epsilon y. You will get some value. That is, let us take as equation 1. Again, nu is 0.3 into epsilon x. Nu into epsilon x, second equation. Nu into epsilon x plus epsilon y is equal to this, you know already, right? If you divide with sigma y by E into 1 minus mu square, you know E value, you know Poisson's ratio nu. So again, you'll get another value. So this is equation 2. If you solve these two equations, you will get epsilon x and epsilon y. If you feel little uncomfortable because you'll get very small values, you can use calculator. You can put two equations, two unknowns, and you can solve the epsilon x and epsilon y. This is one way. This is little bit, you may feel little bit hard, but this is not hard. You can directly from here, you can directly get gamma xy, and you can, if you solve these two equations, simple equations, you will get epsilon x and epsilon y, right? Otherwise I can do again whatever we done in the previous problem. Epsilon x, one second. We can write it as epsilon x is equal to sigma x by E minus mu sigma y by E minus mu sigma z by E. Epsilon y is equal to sigma y by E minus mu sigma x by E minus mu sigma z by E. See, once you write epsilon x, then that will be simply sigma x by E minus the lateral strains, nu into sigma y by E minus mu. You have to put nu. That's it. To the other two directions. Similarly, epsilon y. So you'll get simply sigma y by E minus the other two directions, lateral strains, minus mu into sigma x by E minus mu into sigma z by E. Now you look into z. Epsilon z is equal to, yes, I need to put simply sigma z by E minus mu into sigma x by E minus mu into sigma y by E. Lateral strains for the other two directions, right? Similarly, again, gamma xy is equal to tau xy by g, which is 2 into 1 plus mu by E into tau xy. Gamma yz is equal to tau yz by g, which is 2 into 1 plus mu by E into tau yz. Gamma xz is equal to tau xz by g, which is 2 into 1 plus mu by E into tau xz. Okay, so now these are the three-dimensional, but we know the problem is given as plane. The problem is given as plane stress, right? For plane stress, which is 2D. Okay, you don't need all of this. You know, you need epsilon x, epsilon y, and gamma xy, right? So for plane stress, for plane stress, like a simple plate or a simple thing, whatever the geometry is, but the thickness should be very very small. But in this case, it is given, it is given as plate. Okay, if you say this is x and this is y and this is z, so the z direction, the thickness is very very small. So like we can consider this as plane stress. What is the condition for plane stress? If you recall, if you go back to the previous lectures, you can look into that. Sigma z is 0. If the normal stress is 0, the corresponding shear stresses in that direction, tau xz and tau yz, will also be zeros, right? So if sigma z is 0, if sigma z is 0, then this term will get cancelled. If sigma z is 0, this term will get cancelled. And by the way, we will not need this, but anyhow, this term will get cancelled. So ultimately, we want epsilon x, epsilon y, and this gamma xy, right? Right. So if you take out this, the will convert to equations will convert to you look at here. Look at here. So epsilon x is equal to sigma x by e minus mu sigma y by e. So epsilon x is equal to, if I take 1 by e common, then sigma x minus mu sigma y. Similarly, epsilon y is equal to sigma y by e minus mu sigma x by e. So that epsilon y is equal to, if I take 1 by e common, sigma y minus mu into sigma x. So this is your epsilon x and this is your epsilon y. What about gamma xy? 2 into 1 plus mu by e into tau xy. But in our notation, it is given as sigma xy. In the problem, it is given as sigma xy. And instead of sigma x, we are given sigma xx. Instead of sigma yy, we are supposed to write in this way. We can also write, if you want, instead of tau xy, we are given sigma xy, right? Both our notations are okay. If you want to write in this form, you just mention it and you can write. Otherwise, you can keep it as it is. This becomes sigma xy and this becomes sigma xx, sigma yy, and this becomes sigma yy, and this becomes sigma xx, right? It's up to you. You can write anything. Okay. Similarly, here also you can put epsilon xx, epsilon xx, epsilon yy, whatever if you want. Otherwise, you can write this and you can go with your whatever the familiar notation. Okay. So let us first solve this epsilon x. What is epsilon x? Epsilon x is equal to 1 by e into sigma xx minus mu sigma yy. So epsilon x is equal to 1 by, what is E value? 209 gigapascal. Giga is 10 to the power of 9. I'll write in this way, 10 cube into 10 cube into 10 to the power of 6. Why I wrote in this way, I'll tell you. What is sigma xx? What is sigma xx in the problem? What is sigma xx? Yes. What is sigma xx in the problem? 120 megapascal. So 120 into 10 to the power of 6 minus sigma or nu 0.3 into what is sigma yy? 14 megapascal. 14 into 10 to the power of 6. So epsilon x is equal to 1 by 209 into 10 to the power of 6 into 10 cube. If I take 10 to the power of 6 common, then what it becomes? 120 minus 0.3. 120 minus 0.3 into 14. So 10 to the power of 6, 10 to the power of 6 cancel. If you simplify this, you will get epsilon x is equal to 5.541 into 10 to the power of minus 4. Just a moment. Okay. Now similarly, let's look into epsilon y. Similarly, let's look into epsilon y. What is epsilon y? 1 by e into sigma yy minus nu sigma xx. Or you can write epsilon yy whatever you want. So 1 by 209 into 10 to the power of 6 into 10 cube. I'm deliberately writing so that I can cancel. Actually, giga is 10 to the power of 9. So sigma yy is 14 into 10 to the power megapascal. 14 into 10 to the power of 6 minus nu value 0.3 into sigma xx. That is 120 into 10 to the power of 6 megapascal. So sigma yy is equal to 209 into 10 to the power of 6 into 10 cube into, if I take 10 to the power of 6 common, then 14 minus 0.3 into 120. 10 to the power of 6, 10 to the power of 6 cancel. So epsilon y, if you simplify this, you will get epsilon y as minus 1.053 into 10 to the power of minus 4. That is your epsilon y. Right? So similarly, you can find out gamma xy. Gamma xy is 2 into 1 plus nu by e into tau xy, or in this case, in this problem, we given sigma xy. So gamma xy is equal to 2 into 1 plus nu is 0.3 divided by 209 into 10 to the power of 6 into 10 cube into what is gamma xy, that is tau xy, given in the problem 5 megapascal. So 5 into 10 to the power of 6, 5 will be there. 10 to the power of 6, 10 to the power of 6 cancel. If you simplify this, you will get gamma xy as 6.22 into 10 to the power of 6.22 into 10 to the power of minus 5. Right? So we got epsilon x, we got epsilon y, and we got gamma xy. Right? So that is your sigma, epsilon matrix. What is epsilon? What is epsilon? Epsilon is equal to epsilon x, epsilon y, gamma xy. So what is epsilon x we got? What is epsilon x we got? 5.541 into 10 to the power of minus 4. 5.541 into 10 to the power of minus 4. What is epsilon y? Epsilon y is minus 1.053. I'm deliberately not right. I'm keeping 10 to the power of minus 4 common. Okay. Next, what is gamma xy, by the way? What is gamma xy? 6.22 into 10 to the power of minus 5. If I multiply and divide it with 10, it becomes 0.622 into 10 to the power of minus 4. So this is your strain matrix which we are asked to find. Okay. So now we got the strain. So you have the previous problem also you can solve using that sigma is equal to d into epsilon. Okay. If you feel that it is hard, then you can use these equations. Then stress strain relations, these equations, and you can write all the three-dimensional equations, and then from there, whether it is plane stress or plane strain, you can simplify it. Okay. Thank you so much for listening to me. We'll meet in the next class.